If you take a straight wire and you bend it, you curve it, then what happens is you, inside of this circle, inside of the curve, you get a stronger magnetic field than you do outside of, where there's a weaker magnetic field. You can take advantage of this, theoretically, by bending a copper wire around an iron nail and connecting a voltage source. So as you see, you have the current coming in, and if you use your right-hand rule, number 1, for current in a wire and point your thumb in direction of the current, then you see that the magnetic field is going around. Magnetic field goes around. And if it's stronger inside of the circle, it's stronger along this area, then you have a greater chance of aligning those domains and creating a temporary electromagnet out of that nail. It's fun. Try it. When you do that, when you have that current going through these coils, we call them, then what you're dealing with is a solenoid. And all the solenoid is electric current going in a circle around metal with a really strong magnetic field in the middle. So we are going to get a second right-hand rule for dealing with a solenoid. So it doesn't matter the shape of it specifically. It could be nail. It could be just like bar shaped. Whatever it is. You're going to take your fingers and you're going to point your fingers in the direction that the current is going. So it goes, in this picture, it goes up, and so it's going to go around, and every time there's a curl, or every time there's a turn in that wire, then you're going to come out, right? So you have your thumb pointing to this way. For me, it is my left. That would indicate the North Pole is to my left. It's going to be on the northern end. So when you do this, you have the current going in, and you curl your fingers around that current, and then your thumb will point in the direction of the North Pole. Go ahead, try it out. Label these things. All right, on the first one, current is going in here and coming out there. So my thumb is pointing down, so my North Pole is down here, and my South Pole is up here. For this one, we have the current going in, going down, so my thumb is going to point to the left, North Pole, South Pole. Current is going to the left, so my fingers are going to go like that. North Pole will be at the top. I know I just said my fingers will be like that, as if you could see my hand. I'm sorry. Let's go. A solenoid. Another example of one. Got the current, and you can see the magnetic field lines within the solenoid. They're going to be horizontal. They're going to travel straight through the middle section. And then remember, that's because the flux density is greatest in the middle of that circle as you bend a wire. Electromagnetic applications everywhere. Everywhere. You use this stuff daily. Alright, so try it out for yourself. Go get yourself an iron nail, some wire, and create a solenoid. Well, create an electromagnet would be more fun. And then figure out how can you increase the strength of the electromagnet. If you did it, great. And you found that if you increase the number of turns, you're going to increase the strength. So if you think about that, anytime you curve a wire, you've got a stronger magnetic field in the center. So if you have more current going through a smaller surface area of the nail, then that means you're going to get a stronger magnetic field in the middle. So you're going to align those domains better.